According to the third theorem, if we have two circles and each chord of a circle subtends equal angle at the center, that if we have equal chords, like if you just observe, like A to C is a chord, and we have another chord A dash and C dash is another chord. So if the chord lengths are equal for two equal circles or two congruent circles means that they have equal radius, and in two equal circles, if there are two equal chords, then these two equal chords will make equal angles, equal central angles at the center, like this one. So this angle and this angle will be equal. This is according to the statement of the third theorem. And the same can be applied even to single circle, like if it is a circle and we have two chords, like suppose this is a chord and we have another chord like this one, for example, and we are telling that actually these two chords are equal in length, means like if it is a, if it is B and AB, and for example, if we have another chord in the same circle, it is labeled as C and D. And if we are claiming that these two chords are equal, then consequently their center point, like this is center point, then according to the statement, this angle which is making the end points of chord CD, and if we label this point as center, suppose O, then consequently same chord which makes another central angle. So the statement in fact says that if we have same circle and in the same circle we have two equal chords, like AB chord is equals to CD chord, then these two equal chords will make equal central angles. And this is basically a vice versa statement, means that if the central angles are same in a circle, then the corresponding chords will be equal in length. So these third and number four theorem are actually the converse of each other, and they are stating that in a single circle, if we have two equal chords like AB and CD, then these two equal chords will make equal central angles. Uh, this is according to the third theorem statement. And you can even interpret in such a way that if we have two equal circles, like this circle and this circle, they are equal, means they have the equal radius. So two equal circles, if they possess equal chords, the equal chords will make the same equal central angles in these two equal circles. So these statements are actually linked up in two ways, either two for two equal circles or into a same circle. So this is the statement of the third theorem, and the fourth one is a converse of this one. So I think there is no need to explain the fourth statement. I will just share it with you, and then we will move ahead because we have to solve now if we look at the fourth theorem. So I will just read it. If angles subtended by two chords of a circle at the center are equal. So the theorem statement is about central angles. If central angles are equal in two equal circles, then the corresponding chords are also equal, as I explained you earlier. Now we have to just directly work with the miscellaneous exercise which contain few MCQs, and we will see that how to solve it. For example, first MCQ states that 4 possible answers are given for the following questions. So it states that a 4 centimeter long chord subtends the center angle of 60. The radial segment of this circle is. Now you have to notice that how to get this. For that purpose, I will have to draw a diagram so that we can relate it like this one. So the statement is actually about that if we have a circle, and in this circle we have a chord which is 4 centimeter long, like it is a chord which is making a 4 centimeter long, and this chord will make a central angle obviously at the center. And suppose this is for your convenience, just to explain it further, if it is O is a point and we have A as point and this is B. So AB is a chord and O is a central angle. Then according to this statement, AB chord is 4 centimeter, right? And you will notice that if O is the center of the circle, then O to A will be equals to O to B, because they are the radii of the same circle. So radius is same in one circle. So consequently, OA and OB will be equal. Now you have to see that A to B is provided as 4 centimeter. Now the question comes for this triangle AOB, that AB is equals to 4. And if we go for the angles, that reflects in fact that because two sides of triangle are equal, then opposite angles will also be equal. So this angle and this angle will also be equal, right? So what I can say, that suppose for example this each angle is of value x, right? ABX and other one is also x. So you will have to write in the form of an equation. I will write above that, for example, this angle at which is at point O, like angle AOB, I would write that because both of these angles are equal, because two lengths are equal. So I'm talking about that this angle will be equals to this angle because they are the opposite angles of equal sides in a triangle. So consequently, you need to work it like this one, that x, one base angle of the triangle, other x angle, and plus angle, that is AOB, which is obviously the central angle. This is equals to 180. So if you solve this part, so you will notice that actually we are getting the value of we need to find a o value of length चाहिए आपको O to A, but right now you have to notice के so now if we substitute the value, you will notice that 2x plus, that is 2x plus 60 degree, which is already given as a central angle. So this is equals to 120, 180. And if you solve this equation, so we will get the value of x from this equation as equals to 60 degree. So the point is this, that the central angle was given as 60 degree, and all other angles are also of 60 degree. If the central angle which is given, it is of 60 degree, and we just calculated that these two angles, which is each is labeled as x, this is also 60 degree. So this is an equiangular triangle, and the equiangular triangle is called equilateral triangle. And in equilateral triangle, all sides are equal, all angles are equal. So that's why the correct answer for this one will be that it is 4, right? Option number D, this will be the correct answer. Same in the similar pattern, you will notice the second MCQ, that length of a chord and radial segment of a circle are congruent. If you link up the first MCQ with the second one, it's very clear. Length of the chord and radial segment are equal or congruent, means that if AB is equals to 4, then OB or OA, they are also they will be also of same length, that is of 4 centimeter, for example. If so, radial segment and length of the chord both are equal, then the question is about the central angle. So if you, as I'm telling you that I have just explained in first MCQ, that the radial segment and chord length was equal. So consequently, central angle was of 60 degree, as it was given in the first part as well. And so because if we have done the same MCQ via calculation, so consequently you will be getting the exact answer, that is of 60 degree. And now we will move to the third MCQ. So first and second are related to each other, and you can solve it. Third MCQ states that out of two congruent arcs of a circle, if one arc makes a central angle of 30, then the other arc will subtend the central angle of 30 degrees. So this is according to the statement of the theorem we have just learned in the statement of first four theorems. So this is about the third and fourth, related to third and fourth theorem. So according to this statement, the correct answer, because one arc is subtending a central angle of 40, so the corresponding chord will, sorry, we are talking about the third one. Out of two congruent arcs, if one arc make a central angle of 30, then the other arc will be subtending another angle that will again of 30 degrees. Central angles will be equal. So fourth statement says that an arc subtends a central angle of 40, then the corresponding chord will subtend a central angle of 40. So you have to understand that chord and arc endpoints are same. So for this reference of third and fourth MCQ, I will just draw the diagram that if we have a central angle like this one, and we are making like this is A, this is B, AB, then this is the central angle, right? And as well as chord is concerned, you can see that either you write it as a chord or you write it as an arc. So both arc, AB arc and AB chord have two endpoints A and B. So if the chord is making an angle of, for example, 40 degree at center, then obviously the or arc is making a central angle like AB is an arc and it is making a central angle of 40, then the corresponding chord will also be making the central angle of 40, because A and B are the endpoints of the arc and A and B are the endpoints of the chord as well. So that's why, because the endpoints are same, so consequently the two arc or chord, they will be making equal angle at the center. So this is explanation of fourth MCQ. If we move ahead, a pair of chords of a circle subtending two congruent central angle is, because this is again the related to the theorem number 3 and 4, that if we have a pair of chords and they are actually making two equal central angles. So if you look at this diagram, if I extend it further like we have just made before, and we claim that actually we have another chord right here, it is labeled as C and this is labeled as point D. So if CD is another chord and it is making an angle of at center point, which is point O, this is a center point, this is point O. So according to the fifth MCQ, a pair of chords of circles subtending two congruent central angles, and it is being stated that the central angle which is formed by CD and the central angle which is formed by AB both are equal, then according to the theorem that AB length and CD length means length of the chords that will be equal or congruent. So the correct answer will be congruent. That is the fifth for the fifth MCQ. If we clear all the diagrams and if we move towards the sixth MCQ now, If an arc of circle subtends the central angle of 60, the corresponding chords will make the central angle of. Arc is making us angle of 60, then the corresponding chord will be making a central angle of 62. So the 60 as well. So you have to notice here that it will be of 60 because we have discussed in first 2-3 MCQs. The same sort of question is right here. Number 7, the semicircumference and the diameter of the circle both subtend the central angle of. So it needs some sort of diagram. I will just make one circle right here. And for your understanding, I am drawing a one diameter as well so that I can make it a semicircle right here. And O will be somewhere here. It is a center point. Let's suppose O. And it is now the question is about that semicircle is, for example, this is A point, and on other side, let's suppose this is point B somewhere. I'm writing inside the circle. This is B. So AB is the diameter, and AB is basically from upper side. You can see it is making a semicircle. Now the question is about that the end points of the semicircumference. So semicircumference is normally formed, you can say it's above or below. So the question is about that what will be the angle between them. So you have to notice that end point of the diameter. So semicircumference and diameter of a circle both subtend the central angle of 180 degrees. So you have to notice that your semicircle है, this is above the diameter direction. So consequently, they are making an angle of 180 degree. So semicircumference is half circle and the diameter. So they are making an angle of 180 degree at the center. So central angle will be of 180 degrees. So the correct answer will be of 180 degree. Now move to the next question, that it is 8, 9, and 10. So chord of a length subtending a central angle of 180 degree is always less than the radial segment, equal to radial segment, double of radial segment, none of these. So we need to make a short diagram right here so that we can understand it. So just let me draw one thing, what it is. Number 8, chord length been asked. This is very similar question we have just drawn, right? So that was the last MCQ. So chord length of a circle subtending. So chord, we are taking the largest chord, which is called the diameter. And this is making according to the statement. This is related to the previous MCQ as well. So if it is a making of central angle of 180 degree, so that means if it is 180 degree, then which chord is being used for making 180 degrees? So obviously the diameter is being used, and diameter is 2 times of radial segment. So the correct answer should be option number C, right? So the correct answer is option number C, because this diameter is used. So diameter is double of radial segment. Now, MCQ number 9, if the chord of a circle subtends the central angle of 60, then the length of the chord and radial segment are congruent. Once again, it is very similar to the first two MCQs. Of this same exercise we have already discussed, because circle subtending a central angle of 60 will make actually equiangular or equilateral triangle. So consequently, the length of the chord will be equal to the radial segment. So the question was about the chord and the radial segment. So both will be equal or congruent. Last MCQ, the arcs opposite to the incongruent central angles of a circle are always incongruent, because if arcs opposite to incongruent central angles, so this is very clear. This is about number 10. If arcs are incongruent, then the central angle will be incongruent, and vice versa. So these were the 10 MCQs which are related to this chapter. So I hope that you will understand this.